Welcome to the lecture series Programming in C, in which we will be learning about arithmetic, relational and logical operators. In this module, we will be learning about the definition of operators, arithmetic operators and its functionalities, relational operators and how the relational operator is being applied for relational expressions, and logical operators, logically how to test the relational expressions. So, we will be focusing these operators in this module. The definition of an operator is, it is a symbol which operates on a value or a variable, so that it can be applied for some sort of mathematical function. An operator is a symbol. It can be a plus, minus, asterisk, slash as it is represented over here, that directs the computer to perform certain mathematical or logical manipulations, and it is used to actually manipulate or change the data and variables. Example, we can make the use of the plus operator. The operator plus is a symbol that is used for applying addition operators between two integer values. There are about 8 types of operators in C language: arithmetic, relational, logical, assignment, increment and decrement operators, conditional operators, bitwise operators and special operators. In this module, we will be focusing on arithmetic, relational and logical operators, and the rest of the operators are dealt in the subsequent following modules. The operators in C language are categorized into 3 major categories called unary, binary and ternary operators. Unary operators operates on a single operand. Say for instance, x plus plus is one of, that is plus plus is a unary operator which operates on the single operand x. Binary operator operates on 2 operands, that is 2 values can be given as input for a binary operator to perform its operation. Say for instance, asterisk is one of the binary operator which needs 2 operands for multiplication operation. So, between y is one of the operand and 7 is one of the operand. So, we require 2 operands for performing the multiplication operation. Hence, it is named as, it is categorized as binary operator. Ternary or conditional operator is an operator which will operate on 3 operands, which means we require 3 values for performing its operation. Say for instance, the condition age greater than or equal to 18 is verified, and if the condition is true, the first part of the operand it is getting executed if it is true. If it is false, the second part of the conditional operator is getting executed. So, this requires 3 parts of the data. Say age, if the age value given it is greater than 18, which is a test condition that checks if input value is greater or equal to 18, and printf you can vote. This is one of the expression that is executed if the condition given, that is age greater than or equal to, it is true, and printf you cannot vote. This is expression 2 that is executed if the condition given, that is age greater than or equal to 18 is false. So, this requires 3 operand values, hence it is categorized as ternary operator. So, let us focus on the major 3 categories of operators: arithmetic, relational and logical. So, what are arithmetic operators? The operators which are meant for doing arithmetic operations. The operations are addition, subtraction, multiplication, division and modulo. The addition operator can be used as both unary as well as binary, in the sense that if we want to represent a positive value like plus 3, say a equal to plus 3. So, this in this case we are using only one operand as input, but we are making it as a positive. In this case, this plus operator acts as unary operator. The same expression, supposing if it is used with two operands, the same operator, if it is used with two different operators, then in this case the same plus operator is termed to be or categorized to be binary operator. Similar way, subtraction operator can also be considered as unary as well as binary. It can be treated as unary in case if we are trying to assign a negative value to an integer type variable. In this case, it actually negates the value of plus 3 and it is treated as unary in this case. Similarly, the binary operator also can be treated as a binary operator. The minus operator can also be treated as binary operator, whereas asterisk, division and modulo division operator, all three can only be applied as binary operator, which requires mandatorily two operands for operation. And this modulo operator is given a symbol percentage, which means that can give us the remainder out of dividing two operands or two values. Say for instance, I can use the modulo operation this way. If A value is 10 and B value is 3, so 10 divided by 3, what is the remainder we get? The remainder we get will be 1. So, that remainder will be the output of the modulo division operator. So, here in this case we can see some more additional examples for the arithmetic operations. Say we can see in the first column the operation with respect to C language. In the second column, the arithmetic operators, actually the symbols, how it is being applied, and the third column we can see the algebraic expressions, and in the fourth column we can see how it is being translated into a C expression. Say for instance, if we use algebraic expression f plus 7, this can be converted to the C expression as f plus 7 again. The same way, the minus subtraction operator can also be used in the same way, whereas if we see Bm is a algebraic expression which can be converted to a multiplication operation using the operator asterisk. Similarly, division operator can we can use the same slash operator, and here R mod s for finding out the remainder. In algebraic expression we will be using the mod operator. The same modulo division operator can be used with the symbol percentage in case if we are converting that to a C expression. So, this is a way an arithmetic expression or an algebraic expression can be converted to a C expression. So, here we take an example for practice. So, here we have three variables of integer type A, B and C, and we have two floating point variables of floating point type, say named x and y. So, the expression can be, the first expression is evaluated as A plus B. So, A will be substituted with the value 1 and B will be substituted with the value 2. So, the result will be 3. So, this can be evaluated. Then the second expression is B minus 2 asterisk A. So, in this case B will be substituted with the value 2 and A will be substituted with the value 1. So, the result will be 0. So, if the result is 0, it can be interpreted as false. The second next expression is C minus B minus A. C value is, the value of C is 3, the value of B is 2 and the value of A is 1. So, again we get 0 as the output. So, the result will be false. Then the expression is C minus A, C's value is 3 and A's value is 1. So, we get the value to be 2 and it is true. So, y minus x, y and x are both floating point values whose value is 6.66 and x value is 3.33. So, on subtraction we get the value 3.33 as a result. Okay. Then y minus 2 into x, again y value it is going to be a floating point value which is 6.66, which this value is 6.66, whereas x value is 3.33. So, on multiplying by 2 we get the same value 6. So, it is 6.66 minus 6.66. So, the output will be 0, hence we will be getting the interpretation to be false. So, this is how an arithmetic expression can be evaluated with respect to the arithmetic operators. Then we will focus on learning relational operators. What are the relational operators? It is meant for verifying the relation between two operands. The relation can be is less than or equal to, is greater than or equal to and not equal to. The corresponding operator or the symbols are listed out in the table. You can view the table, I hope so. So, with this you will be able to use the corresponding symbols. So, relational expressions evaluate the integer values to be either true or false. The true or false value, apart from considering that to be a Boolean value, it can even be interpreted with integer values to be 1 and 0 respectively. All of these operators, that is relational operators, can only be binary operators, because we need two expressions or operands for evaluating the relation. We will take again some practice example with respect to relational expressions also. So, that we can consider the first expression, it is a less than c, a's value is 1, c's value is 3. So, we will be getting the output to be true, because a is lesser than 3, and b less than or equal to c, b's value is 2, we will substitute 2 here, c's value is 3, we will substitute 2 here, 3 here, b less than or equal to c, yes it is less than. So, you will be getting the value to be true. So, likewise every expression can be evaluated for its value, and you can see the outputs. Fourth expression is a greater than b, a is 1, b is 2. So, it is greater. So, you will be able to get the result as false, because it is not greater, a is not greater than b. So, we will be getting the result as false. The expression a plus b greater than or equal to true, it is evaluated because a plus b results in 3, c is also 3. So, equal to operation becomes true, hence the result is also true. So, a plus b equal to c, yes it is equal to c. So, you get the answer also to be true. A not equal to b, of course, a is not equal to b. So, the output in this case is also true. The last one is a plus b not equal to c. A plus b, if you evaluate, it is 3, which is not equal to 3. So, this is not true, hence its result in false. And right now, we have seen all the ways of comparing and finding out the relation between two operands. So, all the programs written in terms of only 3 control structures called sequence structure, selection structure and repetition structure. The sequence structure is the way that the statements are executed in order one by one. The selection structure is the one which serves as the branching action, that is, there will be a condition to evaluate, and based on the condition the compiler will be able to decide which part of the statement or which statement next has to be proceeded. And repetition structure is the one we can consider that as a looping structure, where the set of statements will be executed repeatedly. So, whatever it be, the selection structure requires a condition to be checked or evaluated. This is where we use actually the relational operators. So, the condition, the selection structure syntax is if, condition, and whatever the statements you want to execute you can give. In the condition part, we can substitute with the relational operator usage. So, the examples are if age greater than or equal to 18, in which we use the relation operator greater than or equal to. If this condition becomes true, then the statement inside this block, inside this selection body will be executed. If value equal to 0. So, here this is used for checking equality between two operands. Equal operator is used for verifying its equality. Then we will focus on logical operator. There are three major logical operators called logical AND, OR and DOT. So, we can use the appropriate symbols. So, logical operation or logical expression is used for evaluating compound relational expression. Up to now what we have learnt is a simple relational expression where we had only two operands, but here more than one condition if you want to check, if you want to evaluate, then we may have to go for using logical operators. So, the way it can be used is, so this is an example in which A equal to B, this is one relation I am checking or condition I am evaluating, and one more condition is evaluated, B greater than C. Now, we want to verify both the conditions, and only when these both the conditions are true, we want to execute some other statements. In this case, we can make use of the logical operation double ampersand, which is logical AND. So far we have seen only simple conditions on checking or using the if statement, but sometimes we may even have to execute more than one condition, we may have to check more than one condition where we can make use of the logical operators. So, this is the example we can see here, if x greater than 5 and y less than 6, only when these two conditions becomes true, the statement will be executed. In the case of logical OR, we check z equal to 0 or x greater than 10. It means if either one of these conditions becomes true, then the statement becomes true. The last one is if, not logical not operation. This is actually used to check the condition, like if Bob not equal to 42. Okay, the condition result can be negated using logical not operator. So, the example of ampersand, double ampersand is used for logical AND operation. We can here see the truth table of logical AND, which says that if all the conditions, that is only when all the conditions are true, both the conditions are true, the result will be true. So, here you can see both the conditions are true, hence the result is true. For all other conditions, the result becomes false, or otherwise what we can say, expression 1 ampersand expression 2 ampersand a number of expressions will evaluate to 1 or true only when all the subconditions are true. So, this is the case with logical AND operation. If we want to check some conditions where only when all the conditions are true, you want some process to be executed, in those cases we can go for using logical AND. This is the application of logical OR operation, where I want to check if the grade is equal to D or the grade is equal to false, I want to move to the next semester. So, what I am doing? I am just checking if grade is not equal to D or grade equal to false. It means if either one of this condition is true, the result can be true. Only when both the conditions are false, the result will be false. So, in the right side we can see the truth table of logical OR operation, where we can see that if any one of the condition is true, the output will be true. Okay. So, for instance, in the truth table we can see that the first row the value of x is true, hence the result will also be true. In the second row the value of y is true. So, the result also will be true in this case, because the value of any one condition is true here. In the third row we have both the conditions to be true, hence the result will also be true. So, here we can be very sure that if you apply logical OR to the expressions, expression 1 logical OR, expression 2 logical OR and up to expression n will evaluate to 1 if any one condition, any one subcondition is true. So, this is where we will be able to use logical OR operation if we want to check the expressions that if any one of the condition is true, we want the set of statements to be executed. At that scenario, we will be able to apply the logical OR operator. Say for instance, we will take a real world application like evaluating the student's grade. We want to give the student to a rank only when he passes out in all the subjects. So, there we will be able to use the AND operation, because we want all the subjects to be graded as the pass mark. So, in those situations we will be able to apply the logical AND operation. So, in this case I can just make the expression as if the student's score, let me name the student score in various subjects, say subject 1's score, if it is greater than or equal to 40 and the second subject score should also be greater than or equal to 40 if 40 is the pass mark, and subject score should also be greater than or equal to 40. Then he can be awarded with a grade or a rank. So, we can assume a rank value for that particular student, we can assign the rank value to be 1. So, this if condition is used to evaluate more than one expression. All the three expressions are all relational expressions and we can use the logical AND operation to evaluate if all the conditions are true. If we want to do any particular task, we can make use of logical AND operator. The logical AND operator can be represented using the double ampersand symbol. You can make use of the double ampersand symbol for logical AND operation. So, here for the logical OR operation, we can consider an example saying that if the student has reached or if his age is more than 18, also he must be a graduate to vote for a particular election. Okay. That is going to be the scenario if any one of the condition, either if the student reaches his age to be more than 18 or the student is graduated. In any way, if the credit is given, if the credit is to be given for voting, then we can make use of the logical operator in that case. So, here the condition to be checked is if the age of the student is going to be greater than or equal to 18 or it is a pipe symbol which is available in your keyboard. You can see you can make use of that pipe operator. So, if the age is greater than 80 or if he is graduated. So, if he is graduated, if his graduation is 1, then I can allow him to vote. So, we can just put a message saying that he can vote. So, in this case we have allowed the condition any one of the relation, if it is true, then we can perform the task. Okay. This is actual usage of the AND and OR operator for verifying or for evaluating the conditions and to apply for the and to perform the task based on the results of the expressions. There is one more logical operator, NOT. So, this operator is very simple operator which is used for negation operation, okay, in the sense that if the input supplied to this operator is 0, the value or the result will be negated to 1. If the input is 1, vice versa, the result will be 0. So, if this is checked, this is actually used for checking a simple condition, that if we are actually checking the condition of x value to be 2, if we apply a logical NOT, then the result of this relational expression is negated. So, let us consider if the value of x is 2, so this relational operator is evaluated to the value 1. So, NOT of 1 will be actually 0. So, the result will, since the result is 0, this part of the code will not be executed in that case. Okay. So, this is how NOT operation on relational expressions will allow us to do the task based on the input supplied to the expression. So, on summarizing the module's description today, we have learnt on the definition of operators and types of operators. We have seen that there are 8 types of operators, and out of which we have focused particularly on arithmetic, relational and logical operators in this module. Also, we have seen the categories of operator based on the number of operands we supply to the operators, like unary, binary and ternary, based on the number as 1, 2 and 3. And also we have seen how far we will be able to use those operators for selection procedure, selection statements, and we have seen the examples illustrated with respect to every operator. So, thank you so much for patiently listening and learning with me the operators part.